Hi, everyone. Glad to see you all today. And in today's webinar, I'm going to introduce you our software, the Mech Center, Mech Vision, and also the Mech Viz. So you will know what these softwares, what our solutions can do. Okay. So first, I will introduce what the functions of these softwares. And the Mech Center. The Mech Center is a tool that you can communicate with a robot, and you can also manage the Mech Vision and Mech Viz here. And for Mech Vision is a machine vision software where you can apply different image algorithms to process the point cloud. And this Mech Viz here is the programming environment for robots where you can do the simulation for the project. Okay, as you can see here, this is the interface of the Mech Center. Most settings are here in the deployment settings. For example, here you can configure the launching paths of the Mech Viz and the Mech Vision. And these two, the robot server and Mech interface, these are two ways that you can communicate with a robot. If you want to master control the robot, you can use the robot server. And if you only want to send the visual points to the robot and let the robot plan the movement by itself, you should use the Mech interface. So after you have done the configuration here, you can click Connect Robot, and you will set the communication with the robot. Here you can also check the status of the software. You can see the vision and the viz, the service has started. And next, let's see the Mech Vision. Okay, this is the interface of the Mech Vision. Here in the File tab, you can start a new project, or you can simply open a project you have done before. And in the View tab, these are the function windows you can choose. You can choose which function windows you want to show in this interface. And we also have this typical applications. For example, there are depalletizing, positioning, machine tending, and the novel picking. Because we have done lots of projects worldwide, and we made some templates for most common projects. So if you have some similar projects, you don't need to build a project from zero. You can simply use this template, and you can modify some parameters according to the project. So that will be a lot easier. Okay, the next tab is Camera tab, and there's a function called the camera calibration. You can simply follow the instructions shown in this simple tool, and it will guide you to finish the calibration automatically. So it will be very easier. And another thing I want you to know is that we have this point cloud editor here in our toolkit. So normally, if you want to add it to the point cloud, you will need another software. But here in Mech Vision, we already integrate this tool here in the toolkit. So you can simply add it to the point cloud here. Also, you can calculate. You can show the normal of the point cloud, and also you can add the point cloud. You can define how the workpiece is picked, grabbed. And on the left, you can see there's a step library. Here, the multiple steps. they are all integrated algorithms. You can simply drag here in the middle, and you can use them. You can see all these steps are dragged from here, the step library. So there's no need of the code knowledge. And for each step, there are small tabs on the top, and also in the bottom, there are also tabs. For the tabs on the top, these are the inputs for this step. And for the tabs in the bottom, they are the outputs of this step. So you can clearly see what we get after this step. Okay, so now I will take this project as an example to show you how our software works. This project is the metal parts picking. If you double click, just a minute. Some display issues. Just a minute, I will restart the software again. Okay, here, if you double click, you can see the output from this tab. So this is the real workpiece that we get from the camera, the 2D image, the color image. And also we can have this depth image, corresponding depth image of this color image. Okay. So this step is called the capture image from camera. So after this step, we will have this the depth image and the color image from this step. Okay. And here there are some parameters we should configure. For example, here because we have already got the image from the camera, so here we simply load the cameras. We load the pictures from the folder. So we use the virtual camera here, and you can choose the data path where you save all the pictures. So after we get the depth image and the color image, we will need to produce the point cloud. So next step is the point cloud pre-processing. And the depth image and the color image would be the inputs for this step. Here are also some steps we need to configure. So the first step is from depth image to point cloud. Here, you should set the region of interest in 2D. Because there are only some parts in the image that we are interested in. So you can click. Yes. Sorry, I have to restart the software. You have opened it too much. I will start. I will restart again. Okay, let's see. Where were we? Right here. We were setting the ROI. So actually, you can choose where you are interested in and tell the software that you are interested in this area. Okay, so this is to help save the calculation capability. And also here, because the workpiece put on the desk, so you can use the depth image of the background to remove the points. So this is a depth image of the background, and we use this image to remove the background. Okay. And we will also have to set the ROI in 3D. Okay. So we need to make sure that all the workpieces are in this region. Okay. Then we will see what would we get after this step. Okay, here you can see we only leave the point cloud of the workpieces, but there are no point cloud of the desk because we have removed the background. These are the colored point cloud of the workpiece. And we need to do some optimization for the point cloud. We can set a threshold, for example, set the minimum points number as 1,000 and also set a max number. And so with this step, we can filter out the point cloud that has points less than 1,000 and more than this number, okay? So it will be a little bit better than before. So after we have this optimized point cloud, when we continue, next step is to estimate the point cloud's boundary for by 3D method. The reason for this step is because the shape of this workpiece, as you can see here, is a rectangular, okay? So we don't need to match the model using the points on the surface. We only need to use the points on the boundary. So if we only use the boundary, if we only use the point clouds in the boundary to do the match, we will save lots of time. So we can use that we can see what we get after this step. The green one is what we have. Check this. So only the boundary of the workpiece is left. Okay. Then we can do the 3D matching. As you can see here, it says here it's a set of vision steps. Okay, so there are many steps in this step. we can see it's combined of 3D coarse matching and also 3D fine matching. So 3D coarse matching is usually used to find the target objects in the point cloud and obtain their poses. And it's usually followed by the 3D fine matching. Okay, and the 3D fine matching use the outputs from the 3D coarse matching to produce a more accurate target object pose. Okay. So to use this step, we need the model file of the we need a template for the workpiece, and also we have to tell the software the pick point of this workpiece. Okay. So first, we will need to do the template for this workpiece. I will show you how to do it. Here, we still use this point cloud editor. Another way is simply to use the meshed 3D model file for the workpiece, so that you won't have to do it by yourself. Here, I will show you how to do it here. And this is the boundary point cloud for the workpiece. As we can see here, this is not very good because there are points in the middle that we don't want. We only need to keep the boundary point cloud. Okay, so we can simply delete them, and this is better, right? So we can use this as a template, and here we can see the normal of the point cloud. Okay, so this is facing the upward. Then we will have to tell the software the pick point, the pose of the pick point. So which means how to pick the workpiece. You can add a point here, and you can adjust the pose of the pick point. And then we will let the z-axis, the direction of the z-axis is similar to the normal direction, and the x-axis to the long side of the workpiece. Okay, then we have this pick point, and we should save both the model file, the template, and also the pick point. Okay, then we need to import the file here, because these two files are required: the model file and also the pick point file. Here you just made. Okay, both in the 3D fine matching and the 3D coarse matching. So after this step, it will give the pose of all the pick points. Let's see here. This is what we get using the model file and the pick point. But this is not enough. We still have to deal with the pose of the pick points. So next step would be the pose adjustment collection. Do it. Here we can see this direction facing different. The poles of the pick points, they are facing to different direction. Here we can use this adjustment type to adjust them. We have three kinds of adjustment type. One is the align. Second is outwards. And the third is the point to. Okay, so here we use the align to let them face to the similar direction. Okay. Okay, after we have adjusted the pose of the pick points, we can produce and let it give to the Mech width. Okay, this will be all for the Mech vision. The project here for Mech vision is done. Then we will have to do the project in the Mech width. As you can see, the Mech vision already sent the colored point cloud here in Mech width. So this is the whole is the interface of the Mech width. And these are some useful tabs here in Mech width. This is where we do the simulation for the project. Here, here in Scene tab, you can build the model for real objects. For example, the conveyor, the desk, the shield. You can simply load the model in STL format to import the real object model here. And also you can create a model by yourself. For example, if you create a model, for example, the desk, you can adjust the dimension of the desk, any dimension you want. Okay, so here I've already made some objects here in the scene. The desk, the conveyor, also sometimes the shield. If there are a strong, severe ambient light interference, you will have to use this shield. Okay, this is what Scene tab is for. And in the robot tab, you can select robot here. You can select the robot you want to use. Here we have more than 30 brands of robots and the corresponding models. Okay. And also in joint positions, you can change, you can adjust the pose of the robot. Okay. And here in the End Effector and Objects tab, this is for you to import the collision models. And after that, you can do the collision check in the Mech width. Here in this project, you can see this tool is the collision models. And this is how you do it to link the TCP with the collision model. Okay. So you will see this here. And here the rotation symmetry is let you to tell the software the symmetry of the workpiece so that the software can produce more, can plan more picking strategy for the workpiece. For example, here in this project, the workpiece is rectangular, so the symmetry of the here is 180 degrees. Okay, the next step is the workflow. Here you can tell the robot what to do and where it has to go. Okay, here are some basic functions here. First is the move. Move is to let the robot go to a certain position in this space. And also the relative move. Relative move is to let the robot move according to a certain position. Okay, for example, you can let it move according to the current position or the next position. And the DIDO is to control the IO signal. For example, to control the suction cup or to control the gripper. And here is a vision tab. Vision tab here is there's a visual look. Visual look is to let the system call the service from the Mech vision. You can think of it as to take the picture, and you will have these visual points and the colored point cloud here. And then the visual move. Visual move is to let the robot move according to the visual points, to move to the visual points. Okay. So we will simulate this work process, and this work process is the robots pick the workpiece on the desk and then lift it up and move on the conveyor line and go back and to do the whole process again. So let's see. First, you need to set a home place. Okay, so this is the origin pose of the robot. And it has to go to the ready position, so that it doesn't have to go back to the home position every time it has picked the workpiece. Okay, so when the robot is ready for picking, it will have to take a picture and get the pose of the pick point. Okay, after this step, the robot will go to pick the workpiece according to the picking point. Okay. Then the robot will go up and move to above the conveyor line. Okay. This place is we define this place to let the robot to place it here. So we can adjust. We can define it anywhere. And then the robot will, after it has placed the workpiece, it will go up and go to the ready position and do the whole process again. Okay, so we will see what it's like. So as you can see, sometimes there will be highlights here, which means there for one of the planned route, there is some collision, but it will be avoided. Okay, so for any planned history, you can see here. It will show you whether the plan is successful or not. If and then the reason for the failure, you can see, for example, this. Okay. Let's see. for example, for this picking strategy, it says the symmetry fail. Let's see. We can see here the tool has self-collision with the robot. So this move will not be used. Okay. Instead, it will use this move. It shows success. So this is perfect. So this planned route will be used. Let's see the simulation again. So for one pick, multiple multiple routes would be planned. Okay, so if one plan is there is a collision, it will turn to another plan. And if all the plans fail, it will give warnings and the simulation will stop. Okay, that is pretty much the sharing content for today's webinar. So if you have any questions, you can leave them in the chatting room. I can help answer them. Any question regarding the Mech Vision, Mech Viz, or our products?